Hello, welcome student to our channel The Physics Point. And in the previous lectures we are just start to discussions of the application of Gauss law, and in the previous lectures we are discussed the second applications of the Gauss law. Gauss laws, that is application. Let's take the heading. It is application of Gauss law. Gauss law is stated that electricity law of basic law of the electricity, which is stated that the electric flux over a closed surface is equal to the total net charges over the surface and divided by the permittivity of that free space. The permittivity of free space. This is the Gauss law. Electric flux through a closed surface is equal to total charge containing by that surface divided by permittivity of free space. And in these lectures, this is the application number 3. We find the electric field intensity due to the infinite plane sheet. Due to infinite plane sheet. An infinite plane sheet containing a charge, uniform charge. Consider the uniform charged infinite plane sheet with the uniform field intensity. Consider a infinite plane containing charge or charged plane, infinite charged plane consider a charged infinite plane sheet which having the uniform surface density, which have the uniform surface charge density, uniform surface charge density. One of the plane sheet which are containing a charged set infinite planes, and the surface charge density is sigma. It means the q charges will be containing a q charges over the area of A. This is the value of sigma. And this whole system which are situated in one of the medium, and that permittivity of that medium is written like this. And K is the constant of permittivity. This K will be unity in air or vacuum medium. Air or vacuum medium. It means the constant of permittivity is unity in the air as well as vacuum medium. According to the Gauss laws, by Gauss law, the electric flux is equal to total net charges through the surface divided by permittivity of that free space. Let's draw one of this similar diagram here. For consider, this is a plane sheet which are containing a positive charge, and this is a cylindrical shape. This is the cylindrical shape which are passes through the plane charged sheet, the point P, which is situated at the place or tip of that cylindrical shape. We want to find the electric field intensity at a point P, and which are situated distance r from the charged plane sheet, at a distance r, and the both points, that is P and their complement point P prime, is situated from the equidistance, that is r, from the plane sheet. And imagine the Gaussian surface surrounding the cylindrical shape around the point P. Consider this is a point P and one of the surface around the point P which are containing the Gaussian surfaces. And these Gaussian surfaces which are subradius R and the total surfaces. Consider this is my hand is a plain charged sheet and a chalk is like the cylindrical surface or Gaussian surface around the chalk. Surface around the chalk is the Gaussian surface. And these Gaussian surface are containing a area of cross section is A. Area of the cross section is A. We want to find the electric field intensity on that surface or around the point P or the surface of the chalk. We want to find the electric field intensity on the surface of the chalk. The electric field intensity that is E bar, which are directed outward from the which are directed outward from the pointer or outward from the plane of or charged planes. Then we must have the electric flux. The electric flux through a cylinder is E of A up to the point A plus that is E of again A that is the P prime. Because these 2 points are equidistant from the plane sheet, charged plane sheet, and we must have to containing the integrations of the electric field intensity as well as the cross sections area. We must find the electric field intensity of that cylindrical shape. The charge will be distributed uniformly. It means which have the same magnitude at any possible places on the charged surface. Then the total flux, this phi is equal to 2 into E of A. We must know the electric flux according to the Gauss law. This is the electric flux according to the Gauss law, Q upon epsilon, and phi is equal to 2E into A. But whenever we are considering the flux through the total surfaces or the cylindrical surfaces, it must be 0 in the cylindrical surfaces. The electric flux through the cylindrical surfaces, it must be 0, and the electric flux is a tangential to that cylinder. Then equating the both symbols or the electric flux written properly, that is P plus integration that is A of A into this is the P prime. Then we must equating the both because the left hand side of these two equations must be equal, then automatically the right hand side must be equal. Then the Q upon epsilon 0 is equal to 2E into A. E is the electric field intensity. We must want to find this electric field intensity. A is the area of the cross section around the point P, and E is the total charges which are containing the plane sheets, and epsilon 0 is the permittivity of the free space. These are also according to the Gauss laws. Then we must know about the charge. Sigma is equal to Q upon A. Then Q is equal to sigma into A. The value of Q is situated at the place of the Q. Then it is sigma into A divided by epsilon 0. This is must equal to 2E into A. The similar components which are present in the both sides of equality sign, they must be cancelled. It means the area of the cross sections that are present either sides of the equality sign which are cancelled, then we get the remaining, that is sigma upon epsilon 0 is equal to 2E into A. Then we want to find the electric field intensity, that is E. Then the remaining 2 is multiplied with the E. When they are moved either sides of the equality sign, they get divided. Then the final answer of to finding the electric field intensity, that is E, is equal to sigma. This is not a 6, this is sigma divided by 2 into epsilon 0. This is all about the electric field intensity, which we want to find on the cylindrical shape which are situated at the point of the P, which are situated from the distance r, which situated distance r from the charged plane sheet. Okay, what we are consider one of the infinite charged plane sheets, uniformly charged plane sheet. Then they have containing the positive charge, and one of the point P which are situated are from the situated distance are from the plane sheets, uniformly charged distributed plane sheet. We want to find the electric field intensity around the surfaces, cylindrical surfaces which have the cross section area A. The surface is called as Gaussian surfaces. And the point P and P prime are the presented equidistance from the charged plane sheets. Then these are both are equal, electric field intensity are also equal, and area of the cross section is must be equal. Then we are adding it, then electric flux over a cylindrical shape is equal to 2E into A. E is the electric field intensity, A is the area of the cross sections. And we also know that according to the Gauss law, electric field or electric flux is equal to charge divided by epsilon 0, or permittivity of that free space. And both equations having the left hand side are must be equal, then automatically right hand side is equal. Then equating these two equations, this is the equation number 1, and sorry, this is the equation number 2, and this must be equation number 1. Equation number 1 and 2 are equating, then we get the final answer with the help of using the charge, uniform charge density. We are stop here. The next lectures we are start discussions of the next concept except the Gauss law.